Thank you. All right. Oh, jeez. I don't know as I clicked. All right. So, chapter 2, deductive reasoning. We talked about this yesterday, the different types of reasoning. We talked about deductive. Deductive is anytime you use fact rules, definitions. We'll get to that here in a minute. And inductive is when you have kind of common sense. The most broad way I can say is like you're book smart, you have really good memorization, versus you can apply knowledge and create new stuff, like you're street smart. I mean, that's kind of the best way you have common sense. Everyone has both. You know, you can laugh and joke. Everyone's got both. You wouldn't be here if you didn't, right? Because if you just had deductive reasoning, you wouldn't be in this class. You'd be walking from your other class because the only thing you know is you could recall like your list, but you couldn't apply it. You couldn't go anywhere with it. That's why like Kim Peek, he requires a full-time caretaker because he can memorize stuff, but he can't apply it to anything. So if somebody asks him a question, he can answer the question. That's pretty much what he's pretty good at, right? Inductive reasoning, though, you can adapt. Everyone in this room can adapt. I mean, you proved that in whatever classes you've had. In this class, I do a lot of things where I show you problems on the board, and I have you write them down, and then you have to apply them to new problems, because I don't give you your exact homework problems. I make up new ones. So that requires inductive reasoning. You have to be able to apply the stuff I show you on the board and apply it to new stuff, because if I was just testing your deductive skills, I would just simply give you a problem on the board, and that's the homework problem. That's all you have. All you have to do is recall what we did. You didn't have to know anything, apply it. You have to have both to kind of survive in this world. You have to be able to apply and adjust. That's why, like in algebra, what most kids like in algebra is everything's very, very basic, right? Everything is very cut dry. I don't know if like this type of thing. I can tell you how to do it and show you the steps for how to simplify this problem. You can't solve it, but you can simplify the problem down. But if you went to a different problem, like this, somebody that had deductive skills only wouldn't be able to do this problem. They would not be able to do it. The reason why, do you agree that it looks different than the top one? That right there, that automatically says that it's not deductive skills. It looks different. Deductive would be able to recall the exact problem, the exact answer that I had here, and that's all they can do. They can just regurgitate what they see. They don't know how to apply it to something else. You have to have both in a math class. You have to be able to adapt and adjust. Okay, everyone in this room has been able to do that, okay, up to this point, because I don't give you your exact, homework questions. I give you things that look like it, and you had to adjust to it. Some people adjust better than others, I can tell you that. Okay? Now, let's talk about deductive skills. Let's get to that question again, right? Deductive is anytime you use facts, rules, definitions, formula, theorems, and postulates. It's when you can just recall knowledge. Like, for instance, what's the definition of perpendicular? What does perpendicular mean?
The exact opposite.
Perpendicular? Not quite. Not an opposite. Anyone else want to give it a shot?
Oh, correct. I think it's when two things are the same.
Nope. Nope. Perpendicular. A good start. So anyone else want to venture a guess? Perpendicular is on our last chapter test. Perpendicular. Two objects that are perpendicular.
Maybe one is parallel, but the other one isn't.
No. We're 0 for 3 so far. What does perpendicular mean?
They cross paths?
They cross paths, but at what angle?
Right.
Right angles. That's the definition. Two objects cross paths, so they're not parallel. They cross paths, but they form a right angle, a 90-degree angle. Right? That wasn't a good start today, but that idea is strictly deductive. You're trying to recall knowledge that somebody told you earlier. You're trying to find it. Now, don't get me wrong. It's fine to get it wrong. You're trying to make those connections. You're trying to call up that information. Okay? But definitions are things that are deductive. Like, yeah, I have definitions on my test. It's good to memorize things. Okay? Because you're building that connection. You're building that knowledge. I don't just strictly test you on applying it to different things. Sometimes it's nice to have recall. But formulas. Like this is something that I don't have you memorize, you know, on certain cases. Like I sometimes write formulas on the board. That's one less thing that's on your plate, so you can kind of have other things. But deductive skills make students a lot better. So if you have really good memorization, trying to cram in the middle of the night for a test you have the next day, all you're testing on is deductive. You're not actually helping yourself. You're trying to memorize things, but memorization doesn't help you apply it. So that's why cramming doesn't do people any good, unless it's strictly like a vocab test. So just think about that. That really messes with people when they hear that for the first time. Cramming doesn't actually help you, because all you're testing is just straight deductive reasoning, as opposed to inductive reasoning, which is actually being able to apply to something new. So you can recognize patterns and observations. You could people watch for a while and see what they're doing and adjust to it, right? Inductive skills is something that, people that are very hands-on, they want to get practice like looking at something or building. They have really strong inductive skills because they can recognize patterns, what they're doing, and how to fix something, and they can adjust to it. They're constantly manipulating what they do, and they're getting better at it. Because not everything's the same, okay? But it takes a lot of common sense to do that. Common sense is something you can't teach. You can teach observations and patterns and recognizing and how to adapt to it, but you can't teach somebody to recognize the easy ways to do it. They have to learn it on their own. So they have to adjust. That takes pure inductive skills. I want to test whether you guys have inductive skills today. I want to see, can you do this? Okay? Without me telling you how to do it. Because I'm going to put a problem on the board you've never seen me do in this class. Ever. At any point. But I want to see, can you do it? Okay? So here we go. Let's try this out. This will be kind of fun. Alright.
Is this something, is this a problem you've never done math before?
You've never done it for me? Move.
Oh, okay.
Alright. I'll put this on the board. Let's put the stop one. Okay, I'm just going to have this one right here. Just this one. Okay, what I'd like you to do is, this is a sequence. I want you to find the next number that's in the blank. And I've never told you how to do it. Okay? Hassler, what do you got?
23.
23. Okay, let's talk about it. Anyone disagree that it's 23? Anyone have a different guess? Okay, walk me through it. What did it do?
Well, it's basically adding 8 to 8 is 0, 8 to 9 is 1, 9 to 11 is 2, 11 to 14 is 3, 14 to 18 is 4, and 18 to 23 is 5.
Boom. Okay, did I tell you how to do that before you started?
No.
No. Maybe you've seen that problem before. Have you seen that exact problem before? No. That's pure inductive skills. Okay, how many people actually had 23? The people that raised their hand. Good. So you proved right there you have inductive skills. Without a doubt, you have inductive skills. It doesn't matter that somebody raised their hand first. You have the skills to adjust to it. Because I never told you that problem before. You had to figure out a pattern through observation and figure out what the next number is. These can be way harder. Like that was an easy one. They can be way more challenging. Okay? Your skill that you did, where you looked at the 0, the 1, the 2, the 3, that's called a common difference. Okay? This gap that you just found, like this number, is called a common difference. It's one skill that you can use to do sequences, where you look at the gap between numbers. I can tell you right now, the common difference doesn't always work. It doesn't. Sometimes it does, sometimes it doesn't. So, in fact, let me prove that point. I put up another pattern here. In fact, let's see if I got one down the road. Let's see. Yeah, let's do this one. Let's do number 4 here. Try number 4 now. Nice, thank you, have it. Alright, I'll call you first.
It triples itself and then it adds 1.
Aha, you recognize that quick. Okay, that's absolutely right. You didn't hear him? It triples, and then you add 1. Then it triples. And you add 1. Then it tripled. So what's the next part?
94.
You add 1, 94. That's really good. That's hard to recognize that. Because it's not going by that common difference anymore. If you were to look at the gap didn't work out anymore. So if you try that same thing that Hassler did earlier, where you try to do just pure deductive reasoning, add 0, add 1, add 2, add 3, you would fail. It wouldn't be that exact. So you're showing me right now, you have inductive skills. You completely adjusted to a new problem that used completely different rules. Okay? Alright. You got the idea? Let's get to a hard one. Let's get to a challenging one. Those are too easy. I want the next 3 numbers. The next 3 numbers, not just the next 1. I want the next 3. Okay? I hope people raise their hands. I'll call them first. Okay. So we're gonna try some more challenging ones here. There's some on this list here, but okay.
Oh,
That's fine. Give some people a chance here. I'll call them. I got a couple people I'm gonna bounce to here. Pure inductive skills. Every problem's different. Some are way more challenging than others. Chris, do you think you have that next one? Give me the next 1 number.
21.
It is 21. Okay. Max, out you had 2?
34.
34 is next. Okay. Next one?
55.
55. You guys are correct. Now, how do we recognize it? Chris, what did you do first?
1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5.
Good. It's using the previous 2 numbers to make that one. Use the previous 2 numbers to make that one. Okay. It's using previous. It's not using some other pattern. It's using 2 numbers behind to make the next one. That's hard for some people to see. Some people they try to look at the gap between them. They look like it's going up by 0, up by 1, up by 2, up by 3, up by 3 again, up by 2, up by 3. It doesn't jump by the same number every time. Like it's going by kind of a weird pattern. You had to use the previous 2 numbers to actually make it. Now, once you see it, you can't unsee it. Okay, you're looking at it and going, okay, I understand how that works. By the way, that sequence has a name. It's called the Fibonacci sequence. It's how flower seeds grow. It's how snail shells grow. Those numbers actually happen in nature. They spiral outwards on a shell. Let's do a more difficult one. Something that could actually maybe stump some of you. Some of you are getting this way too fast, which is good. Don't get me wrong. I want the next 1 number. Now we get to the difficult ones. Now we get to the ones where people go, I have no idea what they're doing. I want the next single number. You might need a calculator on this one. So you need to go grab a calculator and I'm going to grab it. When somebody has it, raise your hand. testing your inductive skills today. Not so easy anymore, is it? No, it took a dramatic turn. Like, oh man, it's got way harder. Wheeler, what do you got?
The next number is 181, 86.
Nope. It's frustrating. You can't figure it out. What do we do? Anyone else want to take an educated guess? That was good. I appreciate the guess. Would it help you if I gave you the next number? And you can try the next one after it?
Yeah.
It's 216.
What?
It's more confusing now. How do you do it so fast? Just get these out.
Um, 327.
Nope. Not a bad guess, but. Anyone throwing in the towel? Anyone want to know what it is?
Yes.
You want me to wait? Okay, I'll wait. I'll give you time. This is a puzzle. People like puzzles. I love puzzles. Sometimes when you can't get it, you're like, oh, I just need to figure it out.
It's a puzzle in itself, so
It's a puzzle. I gotta figure out the next number. There's the next number. It's in there. It's not random. There's another number. Maybe I'll just leave that one for a challenge. Oh wait.
Is that 369?
Nope.
459.
Nope. I was just throwing out numbers now. I appreciate the guesses, but I know. What is it? I can't figure it out.
I'll throw it in that time.
Once you see it, you're gonna be like, are you kidding me? That's all you did.
That's usually how it works.
Yeah.
Is it 307?
Nope.
Is it 324?
Nope. Man, it's so frustrating. It's so frustrating.
You don't even know what the number is.
I do. I'm going up to the one after it.
Oh.
The numbers get big. You want the next number?
Yes.
No?
Yes. 432.
No?
Are you serious?
43. I'm breaking everyone's minds. They're just getting mad now. Curiosity just turned into anger now. Frustration. Next one's 512.
What? Okay. What the hell are you doing?
Stop going up. Yeah, it's my birthday.
I actually got that on me. Hold on. Does the next number have a 9 in it?
It does use a 9. Mm.
Do the numbers just switch around to add up the next one?
Nope. Here's the most frustrating part. At no point do you ever use a previous number to find the next one.
Are you serious?
I totally broke your mind now. Because you don't use the next number, like any of the previous ones, to find the next one. They're all independent. Next one's 729.
Oh. Oh my god.
Because everyone's trying to like add, they're trying to do every strategy I've shown you so far. Add up all the numbers and then add them up and that's the next one. No, no, no. Every number is independent by itself. Here's the part that really breaks you. To make the number 1, it's 1 to the 3rd power. To make 8, it's 2 to the 3rd power. 3 to the 3rd.
Are you serious?
Of course,
4 to the
I'm
3rd.
done.
5 to the 3rd. 6 to the 3rd. 7 to the 3rd. The only one I didn't know was 8 to the 3rd. I didn't know that number off the top of my head. 9 to the 3rd. Next one will be 10 to the 3rd. It'll be 1,000.
No.
It doesn't require the next number, like the previous number, to find the next one. They're all independent. That's what makes this type of sequence the most frustrating one. It's called the cubic sequence. Cubic sequence. Okay, you're seeing almost every strategy. You just got hit the wall. There's the wall right there. You just hit it. It was that point where all inductive skills and deductive skills failed. You just hit it. Hit the wall. Now, throughout the day, I do not want you to tell any other classes these problems today. Okay, make sure of that. Don't tell them what you did in class. Some people like to know. They ask questions sometimes if we have homework. I don't do. But don't tell them the questions because this is the test I want to see. How many people can honestly find these problems out without knowing it beforehand? Because if somebody spoils it, then there's no inductive testing. Because if you've seen it before, now you kind of know that there's other rules that we can do. Now your brain is completely now open to the possibilities of the types of sequences we can have. Because now you've seen kind of every different strategy. There's others, don't get me wrong, there's more. I have like 20 on this page, but this one usually is the one that catches people. It's usually the one that frustrates. Because everything I've showed you up to this point, I've kind of led you down a path that really messed with you. I only gave you certain problems to really form your brain in a certain way. Then I broke it. Alright. So, eventually we will do more of these. We're going to play other games this week to see how well you can adjust. Some of the games we're going to play this week really are challenging. Taking a rather than that. Some people are going to be good. It showed in the beginning, you guys were really good in the beginning. Okay, alright, let's keep going on some of these terms. We got 5 more minutes, so we're still good here. Okay, we got a couple things I want to discuss today, what I want to get to. Okay, we talked about inductive skills, deductive skills, all that good stuff. Alright, inductive skills again, it's patterns, observations, common sense, but nothing can help you. You have to adjust. That's why you guys hit that wall. You kind of see how it goes. Okay, scientific method. This is a way of using a method of using all of your skills to be able to solve a problem. Here's your steps. Just work. Ready? Alright, scientific method. How in science class they teach this for how you're supposed to address a problem so you can use your deductive and inductive skills to apply to solve any type of problem. You identify the problem first, you have to read the problem, identify what they're asking for. Hypothesize, or hypothesis, is to think about a way of solving it, come up with an idea that you want to test. You want to do your deductive reasoning, come up with procedures, formulas, you're recalling things you've done previously, things you were taught, to come up with a procedure to solve it. You're supposed to collect data, so the collecting data part is inductive skills. You have to apply it and actually recognize patterns and observation, but you have to collect data, and then you have to come up with a conclusion. Okay, valid conclusion, conjectures, if you will, valid conclusions. That's the scientific method. They teach that in every science class, correct? You've probably seen that this year, probably in one of your science courses. That's how they teach, right? Math is the same way. In fact, math has our own method. Okay, this is called the scientific method. We use it in science and math. But math, in every textbook, they always have this, what they call, I think it's a 5 or 4-step plan. It's the same idea. They just use different vocab words. I'll let everyone write this down. Everyone likes to write it. So this next slide is my last one today. And tomorrow we'll play some more games. Games tomorrow are way more entertaining. One second, I'm start writing. Adrian, you're good, let me know. Good. Okay, alright. 5-step plan for math. 5-step plan. Number 1, you have to read for understanding. It's like that identify part. You have to read the problem. What is it asking for? Identify all the things. You have to plan your solution. That's the hypothesis stands for math. You have to plan. What am I going to do? How do I do it? What have we done previously? That type of thing. So you're planning. The planning part is like hypothesizing. That takes a lot of inductive skills. Reading for understanding. That's deductive, or recalling what words mean and putting them together. But planning for a solution is actually inductive. You're trying to plan out. You don't have anything that was told to you previously. You have to come up with a new idea. You have to look at the facts that are given versus what you still need. And then you have to determine operations. That's recall knowledge. What are the formulas that I have? The operations, add, subtract, multiply, divide, or formulas that are up on the board. You have to do computational work. That takes pure inductive skills. You have to apply it to a new problem. Computational is all brand new. And then you have to check your answer. In math, you should always check an answer, but it's a 5-step plan. But it's the exact same thing as your scientific method. It's testing deductive, inductive skills. Some people they check out the minute they have to plan for a solution. They stop there. Because no inductive skills. You have no perseverance. You got to fight through it. You got to at least apply something, try a couple things out, see what you can make sense of. And then you got to do some computational work and then check your answer. Does your answer even make sense? Some of your guesses today for some of those sets were really good, like saying 300 was in that range, or saying that is the next number, I have a 9. Like those are really good things. You're checking an answer. You're coming up with like common sense ideas. But now we have to do the computational work to see what happened. All right, tomorrow we're going to play another game. We're going to play a logic game, which we're going to probably be in pods tomorrow. So just let you know that. It's going to be in pods. Again, don't try to tell any of the other classes what we did here today. Try to keep it safe.